Unboxing time again. New test gear. Or new old. New for me. Old in age. So again, hopefully everything is in great condition. And the box is upside down. The test gear is laying like a turtle on his back. So here it is. So this is a Voltech PM300 3-phase power analyzer. You get this instrument in both PM300, that is 3-phase, and PM100, that is 1-phase. So it has no calibration, ingen kalibrering. That means no calibration on Norwegian. But I think I got it for a reasonable price. It has a stand underneath. And it has a warranty sticker that's not broken. So that's really good, because then I know that nobody has been inside here since the factory, and that's a plus. We got a fan underside here. So Dave at EEV blog took apart a meter like this. That's exactly the same model. So if you want to see inside this Voltech PM300, go and visit Dave at EEV blog, and you'll find his video. Maybe I will link it in the description down below. So here are the input outputs. So we got the voltage, amps, and an external one. So the external one is for if you're gonna exceed the ratings of 20 amps and 1000 volts. So you can use an external shunt resistor. So this one has an accessory, and that's the GPIB port. So I can talk to the instrument with my computer. That's nice. You can also get parallel or RS-232 serial interface, or a chart recorder and alarm contact interface in this slot. So you just change your accessory card or option card. But this one came with GPIB, and that's a plus. It is the calibration went out in January 2008. It has a handwritten serial number, so that's quite personal. So this instrument must be earthed. So connect to power source with ground contact before making any connection to measuring or control circuit. And you can choose between 230 and 120 volts here, and it's at 230 now. So here in Norway we have 230, 240 volts in our outlets. So this meter can measure power, voltage, current, voltamps, VA, var, power factor, volt and amps, peaks, and frequency, crest factors. So it does a bunch of measures. It can measure a harmonic. It has a 0.1% basic accuracy. So it has a max rating to 1000 volt peak and 20 amps RMS, so direct input. But with an external shunt you can exceed those numbers. DC to 250 kilohertz bandwidth. It has a graphics display of waveforms and the harmonic bar charts, so that's great. Integrator for watt hour and volt amp hour, or average and target power factor. I think I want to try to power it up and see if we got some life to it. Hopefully we do. The picture in the advertisement of this unit was of the unit operating, not with anything connected, just the display that was showing that it was powered on. So I'll find a cable here, and now I won't connect my isolation transformer because I want to power it up with a earth ground. So the PM300 is connected to the mains. So let's try to power it up. It has an on-off switch on the back here. The fan turns on and the display lights up. So we got live. It shows the 3 channels and the sum of the channels. So we got volt, amps, RMS, and power. So to test the power analyzer, I'm first going to choose my input. That will be an one-phase 2-wire one-phase input. So we'll go to input, and we have the first option is the one-phase 2-wire input option. So we'll choose the yes for that. So no external shunt, no voltage scaling or current scaling. So we'll go back to the display. So now we just have our one channel input. So here we are at the back side of the unit where the input sits. So I'm going to test a mains powered unit. So I connect my mains in there and there. Then I have my jumper somewhere. Then I have my jumper lid that goes from the low side to the high side on the amp scale or amp input. Then I'll take my cables out to the source, that I'm going to test. I have a socket like this. I'll take my leader and my neutral on the low output here from the amps. So now I should be able to measure both amps and volts and power on this unit. So my first DUT, device under test. So how power effective is the old Heathkit capacitor checker? Let's figure it out. So I connected the capacitor checker, power it on. So we started at a 0.800 in power factor. So we'll see as the Heathkit heats up. So the power factor should be at the best 1. So it's 0.7 now. It decreased a bit after heating up. But not much. So I wonder if I had recapped the old Heathkit, would I get a better power factor? So this will be something to experiment with at a later moment when I'm repairing and recapping devices. See if I get a better power effective device after the repair and the recapping. So that will be fun to see, because it, as the caps charged up, the power factor went down. Okay, so before removing the Heathkit, I want to test the waveform on the power analyzer. So we go into the menu, then modes, then we go to the waveform, check that, take fast mode. If you disable blanking, you'll see more of the low signals. So the blanking is cutting out the lowest signals. I won't disable it now, but maybe at a later test. So we get only one cycle of the waveform displayed, and we get peak measurements here. The next waveform we will see when I turn on the Heathkit again is the waveform for current. So let's see what we get. So there we have the current waveform. That's quite cool to see. So So I really like the power analyzer so far. It looks like I got an analyzer in good condition. That's really nice. So let's do a real power factor correction. I got this Ecotech motor. It's from an Ecotech water maker. That's gonna be mounted back into a sailing vessel. So I have changed the bearings and refurbished the water maker pump. So this motor is connected to a hydraulic pressure pump that pressurizes the salt water into the filters, and you get fresh water out. So because it's connected inside a sailing vessel, you have a battery bank with an inverter, and you want to lower the power consumptions of the equipment on the boat to the minimum. And if this motor has a bad power factor, I can lower the consumption a bit. If it's really bad, I can lower it quite much. So instead of drawing what manual says, 11.3 amps at 230 volts, so you can either have it connected like a single phase 230 volt or a three phase in 220 to 380 or 440 volts. At 380 volts it will draw 3.8 amps, and that would be quite ideal. Try to get it in focus here. But it's connected like a single phase 230 volts, and the specs here says 11.2 amps, and I'm not sure if that is with high pressure hydraulic pump or without it. Most likely with it, because that will be quite a load for the motor to turn. But let's try to test it, see what the power analyzer says. So I have hooked up the motor as a single phase. I can't use my variac to soft start it because it draws too much current and just blows the fuse on my variac. Let's see what we get out. Then I will plot my data into a power factor correction calculator and get my specs for the capacitor I should power correct with. So let's test it now. It will start with a small bang, and because this is just on off. So the power factor is 0.24. Frequency is 50 hertz, of course. So I need my voltage. So this is at 235 volts. Current 10 amps. 9.94. So I need my KV So then we have our data. So let's plug it into the calculator and see what I need for a cap to power factor correct this motor. I think this was a really bad power factor to get out from this electric motor. 0.24, it's so you should be as near as 1 you can, but usually you use 0.95 when you calculate your power factor capacitor. So here I have the Rapid Tables power factor calculator for calculating the power factor correction capacitor. So I'm on single phase, then I'll plot in my real powers in kVs. So it's 0.567 kVs. Current in amps 9.94. Voltage in volts, so I'll use 220 volts AC, 50 Hertz, and the corrected power factor will be 0.95. Let's calculate and see what we got. Power factor result 0.259, and we measured 0.240, so that's quite near. If I change my voltage in volts to the measured voltage, that's 235. Then we got 0.243, and we got measured 0.240 in power factor. And the kVA we measured 2.32. Here we got 2.33. Reactive power, kVAR, we got 2.27, and here we have 2.266, so near enough. But to power factor correct the motor, we need a 119.8 microfarad cap, so I can buy a power factor correction capacitor, but that's quite expensive. We are talking a couple of $100 for a capacitor, and I don't think it's worth that. But another option is to buy a run capacitor, motor run capacitor. So you got a motor start and motor run capacitor. A motor start capacitor you can't have connected in the runtime, so you need to have it connected so it switches out when the motor has started. But the motor run capacitor, it can stand and be connected to the circuit all the time the motor is running, because of the name run capacitor. And the run capacitor, I think I can get at 100 microfarad. I'm not able to get 0.95 in the power factor, but I think we'll get near enough. I can try 0.9, see how 0.8. Yeah, it will be at 0.75. So, but it will be a correction from the 0.240 that we had before. But I'll see if I get a better capacitor than 100 microfarad in run capacitor. I will buy that. So I've got a power factor correction cap hooked up in parallel with the motor. So let's try to power it up and see what we get out on the power analyzer now, after we have corrected the power factor.
So hopefully we get some better numbers now. So now we got 2.92 amps and 653 watts. Let's see the power factor. Look here, 0.94. So we have really corrected the power factor now. So yeah, we got a good power factor now. That's really great. We are up in 3 amps.